In this video, we're going to go over while loops, the last tool we'll cover in Engineering 120 for controlling program execution. Our objectives are to use while loops to implement iterative program execution based on a condition or the result of a logical test. We talked last week about how to formulate various logical tests. Then we'll also want to be able to combine while loops with all of the other programming techniques we've learned to use MATLAB to solve a variety of problems. So let's look at the syntax for a while loop in MATLAB. The way this works is we use the keyword while, and then we have some logical test. For example, x greater than 5 and x less than 10, or something like that. Some sort of logical test. And as long as this is true, if that's true, then we execute all the commands in the loop. And the commands execute, the loop repeats infinitely until it won't execute when the logical test equals false or 0. So let's look at an example while loop. So in this while loop, we're going to repeatedly divide a number by 3 until the result is less than 1. We also want to count how many divisions are required. So here we start an initial value for x equal to 100. We will initialize the counter. And then we enter the while loop. One note is we have to make sure that this condition must be true for the first iteration, or the while loop won't happen. So that's one key here. We want to make sure that that is true for the first iteration. So we're actually using the converse, and since we want to go until the result is less than 1, we will loop while x is greater than or equal to 1. Then each time through the loop, we'll divide x by 3 and then increment our counter. Note we don't have any sort of incrementing variable like we do with a for loop up here. So the way to increment a counter in a while loop is just with this statement, count equals count plus 1. That's a common thing that you want to do sometimes in a while loop. So let's go over to MATLAB and step through this and watch what happens. Okay, so here we are in MATLAB, and what I'm going to do, I've set a breakpoint here at line 1, and we're just going to step through this code with the debugger and see how this while loop works. So as we come in, we're about to execute the value to assign a value of x. So I'll step through, and we see down below here in the workspace, x equals 100, then count equals 0. Now we enter the while loop. Now if this condition, x greater than or equal to 1, if that were to be false, we would never enter the while loop. The next step would go down to line 7, which would end this function. So we have to make sure that condition is true, which it is, since x equals 100. So since it's true, we'll go into the while loop, and then we replace x with x over 3. We see now x equals 33.3, and increment our counter. Now we go up, we check the condition again, divide by 3, increment the counter. You look down below what's happening with our workspace as we work through this loop. Come back up, check the condition, x equals 11, that's still greater than or equal to 1, so we'll execute the commands in the loop, increment the counter, come back, x equals 3.7, the condition is still true, so we execute inside, x equals 1.2, the condition is still true. Now we will divide by 3, so now x is less than 1, but we still haven't gotten back to the while statement, so we're still going to execute the rest of the commands in the loop. So we increment the counter to 5, Now we're back up at line 3 and checking the while condition, and we see that x equals 0.4, so the condition is false. It's not greater than or equal to 1. So you'll see our next step is the down arrow, which means we are done with the function. So let's go back over to the presentation. So we've looked at flowcharts for these different ways of controlling command execution in a program. We looked at the for loop, we looked at the while or if then, if else statements, and now here is the flowchart for a while loop. We'll see it's similar to a for loop, but the difference here is the for loop was testing if the index had exceeded the maximum value. Now we're just checking to see if a condition is true. If that condition is true, then we execute the commands. If the condition is false, then we come out and we go to the rest of the commands. And again, using these flowcharts can be a helpful way to understand how the code is working if you are a visual learner, and it helps you visualize the order of the command execution. So one thing that you might have noticed with the while loop is that we can accomplish a similar code without a while loop. So here's a piece of code that does the exact same thing almost as the previous example, which I've shown again below. This is the previous example. In this code we don't use a while loop. Instead we're using the combination of a for loop with an if statement. And basically what we've done here is now the count, we don't need this increment. The count is just incremented by the for statement, but notice I've had to, this is essentially, we're running this counter for infinity is the idea here, because the while loop means run forever until x is less than 1, or run forever as long as x is greater than or equal to 1. So now we just want to run forever. We'll divide x, and then we'll just say if x is less than 1, we're going to break, which means leave the loop and continue with subsequent commands. So this is something we already have the tools to do the same basic programming as the while loop, but the key here is that the while loop is just more concise. You see, we don't have to have two nested structures here. It's just one simple structure, and in general it's preferred, more concise and preferred. So you can think about the while loop as doing something that you basically already know how to do with for loops and if statements, but it's a more efficient way to write that code. Let's look at another example. We looked previously with for loops at generating a Fibonacci sequence. In the previous example in that video, we had generated the first n numbers of the Fibonacci sequence. So now we're going to look at a slight twist where we will generate a vector of all the Fibonacci numbers that are less than some number. So here's the function, the input n, and what we want to do is generate all the Fibonacci numbers that are less than n. So for example, if n is equal to 10, we would want to generate a vector fib that's equal to 1, 1, 2, 3, 5, and 8. And so let's look at how this works. We again generate the first two. Note, I'm not using pre-allocation in this example because we don't know how big the vector is going to be. We don't know the ultimate size of fib. We're just going to keep generating Fibonacci numbers until they get greater than that input n. So we just generate the first two numbers, and then here we'll start the counter. And in this case, this counter is also going to keep track of our position, our index, inside the fib vector. Then we will set up our condition, and you could set this up a number of ways, but in this case I just said while the maximum element in the fib vector is less than n, we're going to keep generating Fibonacci numbers. So using the same code that we did before, fib subindex is equal to fib subindex minus 1 plus fib subindex minus 2, or the next Fibonacci number is equal to the sum of the previous two Fibonacci numbers. Then we have to increment the counter, and we're just going to keep doing this as long as the maximum of fib is less than n. Now one thing that you'll notice is that if we do that, let's say we get to the point where fib equals 5. So if we're at the point where fib equals 5, let's say we get to the point where fib equals 8, and we get to that point where fib equals 8, and 8 is less than n, if n is 10. So 8 is less than 10, so this generates, and it generates the next Fibonacci number, which would be 13, 8 plus 5, so 13, and then it increments our index. Now we go back up, and now it will have already generated that number 13 and put that to the vector fib, but now this evaluates as false, and so we get, when we get to here, fib end is equal to 13 in this example. And so this command just deletes the last element. Just saying fib end equals the empty brackets. And that's another thing that you'll have to watch out for sometimes with while loops, especially when you're working with vectors, is you might get one more iteration than you want based off your condition. Sometimes you can change the condition to fix that. Sometimes you can change your strategy for what's going on in the loop to fix that. And sometimes you just have to fix it after the loop. So in this case, I'm just fixing that after the loop by recognizing that no matter what, this while loop is going to generate one extra number, one extra Fibonacci number. And so here we just delete the last element of fib. And this one I'm going to let you try yourself in debug mode, step through this for a variety of inputs and make sure you understand how this function is working. So we've looked at a couple examples of while loops and talked about a few cautions to be careful of. So let's go over that again. So they can lead you into trouble if you're not careful. First of all, the logical test must start out as true or the loop will never start. So we need to make sure that that loop starts or it's not really doing anything. Secondly, the commands inside the loop at some point, they must change the result of the logical test to false at some point, or you'll have an infinite loop, meaning it will just run forever and it'll seem like MATLAB is hung up and not responding. If that happens, and it's almost guaranteed to happen as you learn how to program with while loops, what you can do is just use Control-C to break out of the program, and it should return you to the command window. The other thing we talked about is that when we're using while loops, we must be careful and make sure that the logical test does not result in one extra iteration of the commands inside of the loop. Extra compared to what we need to solve the problem. So if that happens, we mentioned a few ways to address that. One, we can modify the logical condition if that's possible. Two, we can modify our strategy and or our commands inside the loop. Or three, we can just fix the result after the loop. So in that, this is like we did in the fib example for the Fibonacci numbers. We just deleted the last element of that vector, and that fixed the problem. So let's summarize all these different strategies for flow control in command execution that we've introduced in the last couple weeks for MATLAB programming. So for one, the default is always sequential flow control. In other words, the commands are executed one at a time in the order they are written. then we have some options to deviate from that. One option is iterative flow control, where we execute a set of commands sequentially. They're executed sequentially, but we repeat that sequence of commands either a fixed number of times with a for loop, or while a certain condition or logical test is true, and that would use a while loop. And then our other option is that we can use in combination with iterative flow control is conditional or logical flow control, wherein we'll choose which set of commands to execute based on the result of one or more logical tests. And we did that using the if, else if, and else construct. And that concludes this video on while loops, our last material for Engineering 120.